live remotely and tell us something about your Monica device. So can you
I hear very faintly. Are you talking to me? I'm Saverio. And I cannot understand what you are saying, basically. Hello?
you hear me? You hear me?
Now.
Now?
Yes.
Okay. So we have now afternoon session, and in afternoon session we will have some exercises and field campaign, and we are going to present to attenders Monica and Klimerko Pro device. You know that Monica was and Klimerko Pro device was collocated not so near, but in some vicinity of automatic monitoring station where is Serbian Environmental Protection Agency located. And now Monica and Klimerko Pro are here with us in Borkovac, and we, DUŠKA and MILOŠ, are going to do that. Just we want some introduction about Monica device.
Okay. First of all, thank you. I'm very sorry not to be there. As you probably know, I'm still positive to COVID, and I'm waiting to become negative. If this happens tomorrow morning, I will take a plane and I will just jump right to you for my session on Thursday. If not, we will have it by remotely. Unfortunately, I got COVID 10 days ago after 2 years, and I was it spared me for 2 years, but this time I got the famous Omicron.5 mutation. Anyway, so we are here to present a little bit what we are using in our field exercises and research experiments. As Miloš may show probably, we have devised this system some years ago. It is called Monica. Monica is a female name in Italy, but basically it stands from monitoraggio cooperativo della qualità dell'aria, which means cooperative monitoring of air quality. The idea was actually devised in 2014, and back in that times it was really a huge advancement to let people monitoring air quality by their own. And sharing the data together would have allowed us to build high-resolution maps of air quality. This result has actually been achieved last year in the framework of a project called Urban Innovation Action Air Heritage. I take the name on the chat. You can find it on the Urban Innovation Action UIA framework, EU funding framework. We will talk a little bit about it also on Thursday. But by the way, we decided years ago to rely on electrochemical sensors. And if Miloš may show you the device that I see on the table, thank you, DUŠKA. It is made by a very simple case containing 3 electrochemical sensors. These electrochemical sensors come from AlphaSense, and in the literature you can find that they have shown very reliable in this kind of application, and also has a sufficient accuracy and precision. And that's why we choose that kind of sensor some years ago. We had the opportunity, together with DINCA and also with NILU, to have some joint exercises with the EU net air cost action, and this hypothesis on their accuracy was confirmed, and actually we managed on a short time to obtain results that were compatible, that were in the range of the EU 2008 directive on indicative measurements regarding the quality of indicative measurements. So we qualified for indicative measurement as reported in 2008 directive. That's why I was very interested this morning to understand what would be the influence of the new directive that we will see in the next few months. By the way, we calibrate these systems, these sensors, by using field calibration methodology, which actually was devised by us back in 2008. We were the first to try this approach in 2008, but we used at that time metal oxide sensors that, by the way, they are returning into use because huge issues in terms of drift are quite about being solved. By the way, as you see, the three devices, the three systems, three sensors are connected to an analog front end, which is a commercial one and comes exactly from the same company that actually devised the sensors. So we bought the same units and the analog front end. The analog front end is then connected to an STM32 from ST Microelectronic Nucleo board, which is an STM32 microcontroller device-based board, and this board hosts a firmware that we have developed that actually interrogate the sensors, obtain the data, and then use a transponder to send the data. In this version that you see, you will see a Bluetooth low energy transponder, and this is used to send the data to an app, a smartphone app, or for fixed implementation to a single board computer based on Raspberry Pi version 4 that you should also see on the table somewhere. When we started the Air Heritage project, we also we designed a new version, and we decided to implement also particulate matter monitoring. And we included in our battery, in our sensors array, Plantower PMS 7003 particulate matter device. This device actually estimates the number of particles in dimensionally partitioned bins. So we have as an output a number of particles in different dimensional bins. We have actually PM 0.5, PM1, PM 2.5, PM5, and PM10 particle counters. Starting from this data, we can devise a calibration in order to obtain an estimate of the concentration of these particles. But in truth, they also has on board two different calibration, which actually do the same. And so the devices are actually capable to estimate directly the concentration of particulate matter in terms of PM1 concentration, PM 2.5, and PM10. Okay, we go further by developing a calibration which correct for the influence of relative humidity. So as we correct for non-target interference and temperature interference, the readings coming from the electrochemical sensors, we also correct the data coming from the particulate matter sensors in terms of relative humidity, because as the literature, as you can find in literature, it has been shown that these optical particle counters suffer from interference from relative humidity. So when the relative humidity is more or less higher than 70%, what happens is that a layer of humidity of water is forming on the particles, modifying their size. Since their calibration is based on hypothesis in terms of weights of this of a particle of a particular size, then their estimate fails. Okay, so we have to correct this influence, and we will show on Thursday which kind of approach we are taking currently, and we also an approach that we also want to further develop in a research visit that DUŠKA, DANKA, and MILOŠ will pay to us in the next weeks, and we are very happy to have them here physically. By the way, more or less, this is what we can say regarding the Monica device. If we have further, let's say 5 minutes, I can show you actually by using some presentation what we do with the data coming from the sensors. I can actually show you the interface that the users say when they use this device in mobility. So if you wait just a minute, I'm connecting and showing you. Let's see. Okay, I'm trying to show you the sharing the okay, we show the entire desktop. Okay, and you should be able sooner or later to see this. Okay, so do you see the Urban Innovation Action web interface? Hello?
Yes, we are here.
Okay, thank you. So let's try to access as a registered user. Okay, this is what the citizens see when they enter the interface. Okay, so apart from data coming from fixed station that you can see here, they are deployed on the city of Portici, which is actually where I'm living now. Actually, I am here. Let's see. I am here now. Okay, they can see the data of their Monica session. So if we go some months when last time I have monitored, which is more or less in December. So let's take a look at what I've done in December, just one session. Okay, you can hear it, what happened that morning when I went to work. So people say their the track that they have followed. Okay, and here you see that there is a crossroad here in which the air quality worsened, and also here this is a famous canyon here in Portici, which I will be very pleased to show to our guests. And this is the research center right after the sea. And people can also show some charts regarding PM, for example, and they see what they have monitored during their mobility session. And that's basically what they can do there. Of course, they can download their own data here, and they receive a CSV data with estimation, or they can also include raw data. And this is very interesting. And these data are then shared, and what we do is to build this kind of maps, as you see, and every small dot here is 25 by 25 meter, and we are able to reconstruct this very high resolution data by high resolution maps based on the data gathered during measurement campaign. As a calibration approach, we have chosen to recalibrate every 6 months these 30 devices that have been used in this project. And as I will tell you also in detail, this has been a nightmare in terms of logistics, but we managed to get this, and this is the highest level of quality for the data that is attainable with this kind of sensor with repeated recalibrations. Okay, and that's basically all for my side. If there are some questions, please, I'm here to answer you regarding this. And of course, these devices are there, and 8 of them are now in Vincia in order to be also part of comparisons with the Klimerko devices during the UNICEF project.
Thank you, Saverio. Now you will be here, and if there will be some question, we will be back in
okay.
next half an hour or hour.
I am connected. It's no problem. You just take care if that I'm showing negative tomorrow morning. Tomorrow night I will be there. Tomorrow night I will be there. So just I won't take a sack pack with me. So I will need a small space to sleep. So
you are not only one that is positive. There is one attender, and Svetlana Stevanovic, but you look like you're really ready to travel.
Actually, if I don't test negative, they won't allow me to move in any way. So let's hope tomorrow morning I will show negative. I have here with me, let's say, home test that I will run in a couple of hours. I will keep you posted.
Okay, so DUŠKA and MILOŠ, the floor is yours. Ćeš ovdje DUŠKA da dođeš? Ne, ne. Okay.
So we'll continue talking about Monica devices later, because we have them set up outside, and they are currently measuring the air outside of our conference call. And we also have two Monica devices and 4 Klimerko Pro devices online now. So in the second session of this part, we will have a small practice outside, practice exercise, and we will monitor Monica and Klimerko devices live. But for now, I would like to show you Klimerko devices and also the portal that we use to monitor their measurements. So this has been developed. I will use my camera to show you. But you can see it. I have another open one over there. And you will see them in action, and also you can see these open ones as well. So they have, this one has a PM sensor here. Oh, here's this camera as well, okay. Let's go. It's happening now, okay. We have 3 cameras. Okay, never mind. Okay, so Zahir is now showing you the setup outside with the Monica devices, and you can see the Raspberry Pi that is driving the Monica devices, and the 4 Klimerko devices in blue and white 3D printed cases. And here you can see on my camera one of the Klimerko Pro devices that has both. This is these 2 are gaseous sensors, the NO2 and the SO2, and this one is the PM. And so it was developed by Internet Society of Serbia. They have developed something similar before, and this was specially designed for the UNICEF project and printed in these cases. And they also developed a platform that we use to monitor measurements live, and they've developed a platform to be used in schools. So teachers can log in and track measurements for 3 devices that are installed in their school. So we have 45 schools in this project, and every school has 3 devices. One of them has all 3 sensors, because we have various kinds of sensors. Most of them have only PM sensors, and some of them have both for the gases, and some of them have only NO2 sensors. So each school has one of a kind, so they have 3, and they will be using them to teach the children how to keep track of the air quality. So the platform is still not live. I can show you what it looks like now, but so this is the platform they will use for schools. This is their end goal. And we are now logged into we have an account at the Institute, we can monitor, but they also made accounts for schools. So each school will keep track of the measurements for the devices that are mounted on their outside walls of the schools. And they are currently only measuring PM particles. So you can see this. This is this is because we don't have any. This is an old measurement that is stored in the system right now, because we are not connected to the live system yet. So this is not fully operational, but it will look like this. So you can choose which measurement you want to see. So hopefully that will be live soon, but for now we keep track of the devices using this platform, and when we go outside we can see that we can track data by so we can track data by device. We had 150 devices, as you heard in the presentation that MILOŠ held a while ago. So it's a bit of a challenge to monitor them, but the good thing is that the schools will only have 3 devices each, and it will be easier for teachers to explain to the children and to keep track daily of the changes in the air quality. So
somebody.
So we will use this platform later to track the data here live by one device. So we have 4 devices currently online outside, and we can use the device ID to track the last 100 measurements. And we have few of the devices that will be Okay, a few of the devices that will be outside, that are outside now, have all three sensors, and a few of them have only one has NO2, and I think one has only PM. So we can, when we go outside, we can monitor live, and we will try to change the conditions and see what happens.
Just a few more things about this project. It was very long in the making, actually, and that is actually the way it works with UNICEF. It's a bit different than the typical funding calls, because actually they start with an idea and then go around to gather a team, and then as the time progresses, they may or may not find the resources to complete the project. Actually, this is part of a bigger project. You may have maybe had the wrong impression, because we had a number of presentation here about the calibration of the sensors and so on, but actually it's a much bigger project, at least maybe an order of magnitude bigger. So the VITO project, which is already complicated, and it's devoted to calibration and deployment and recalibration and control of the sensor, it's actually long and very intense project, but it is like a tenth of the whole UNICEF project that is devoted to schools, to engaging children in various activities around air pollution, and about raising awareness about air quality. And hopefully these little devices will help in doing that. It was not the scientific part that you will see here, and in the following days of the school is only one side of the project. There is typically there is a number of additional activities that relate to motivating the local teams, engaging them in the workflow of the devices, ensuring that that everything works as intended to be. VITO was, in addition to these, in addition to the quality part of the project, we were also engaged in making suitable questionnaires for the end users and local stakeholders, to making small field manuals on what to do, how to where to put the devices, and so on. And I don't know if DUŠKA and Uzahir are ready. They prepared a small experimental setup just outside the terrace here. They connected several devices, and you will be able to see how they stream data to the cloud.
No, we are asking first for the feedback from you.
From us here, like here.
Yes. It is not still, yeah. It is just that needs to be clear, visible, and accurate for children, from professors, from different kinds of stakeholders, and we will be happy if we'll go to prepare some questions tomorrow, just to
tell us how you, what is your impression about that we are going to forward it to UNICEF and to discuss with them. We think that is important. Excuse me?
No. The platform. Okay. The platform is not live yet, so this is just we can't log into the school platform here. So we can log into our account, but this is just some data they stored a while ago, just for example. But it is good also for us if you can give us feedback on the visibility of this kind of display of data. So this is what they came up with for children, and we would also like to ask your opinion about how you feel about this. So this is just some core data that is for our account. Every school it has its own password and we can access only the devices that are installed at school. So they will have 3 devices and they will have this kind of display for tests.
Yeah, but data represent like concentration, low concentration, or the index for the children.
Yeah, it is concentration, and actually there was a long debate for the content on that will be shown on the website, and we have agreed about what limit values should be shown and what averaging should be used and so on. But there was also an issue because sometimes because of the noise, some of the sensors, for example, some of the sensors when they have low values of gas pollutants, they can show small negative values. That data is not something to be automatically marked as outlier or automatically discarded, but for the children it's not really suitable to confuse them with what's this for the quantity that should obviously be positive, what's this close to 0 but negative value and so on. So those kind of we had discussion how to visualize that, how to mark it, to exclude it and so on. And additionally, regarding the outlier data, from when you're just looking at the data, you can apply some statistical criteria on what is outlier. For example, if you have large values, you can, if there are some 99 percentile of the data, you can maybe this on the basis on statistical reasoning, you can discard it as outlier. But we also discussed that each school has a place in the portal to enter specific episodes of pollution that are specific to that school. For example, if there is some fireworks or if there is some local biomass burning and so on, so they can enter that into the portal, and then later when the monthly reports are generated, you can pinpoint, for example, if something is truly an outlier or if it was a result of some local pollution episode. And we also hope that in that way we will actually engage people to use the platform and to really have their comments enter the monthly report that will be published on the UNICEF website. Can we proceed maybe with the exercise?
Maybe there is another question.
Yeah.
More questions? You can come and see the device if you want to open devices, see the sensors, what it looks like, and then we can go outside and the Monica device is there and the two Klimerko devices are here, so you can go outside and here.
Posle 4 minuta se vrati u ono. Ajde, već moramo desiti. Dakle, dosti ne brzo. Fascinantno je što se ništa nije zagrljeno.
It's very positive. And she's not easy. She has positive and maybe when very just very positive. Also, she put the same.
Gledaju ovi monitor, naša pravna.
And if it's anyone more, just prepare the topic.
Još ide produžni za Klimerko i još
5. Zašto ga sad nema?
Zašto nemamo projektor? Zašto je ištek?
Sorry? Going to
Aha.
see you sometime tomorrow morning. Okay. Make sure it's recorded because I have a meeting with them by my vacancy and I don't know how long it will take. Okay. And I really want. I'm sorry. I feel like. I mean, I'm really upset, so I'm trying to think about it. So, how long did you want?
I need to prepare the presentation during the night because I
didn't go to the we had one more.